Hello. So I'm glad to see all of you today, even if my face says otherwise. um, my name is Alexander. I'm more than 10 years in IT. Currently, I'm engineering manager, and for previous 3 years, I was in reliability. Why reliability folk here on QA meetup? Because quality assurance actually contains reliability. It's quite important to think of this one. So, and today I will tell you about how to use criticality tiers for great good. Before we start, I would like someone to help me. I need one volunteer. No, not you.
Not me, okay.
I just need some simple math. Please raise your hand. All right. You. So I will ask you to count how many times I will say microservice in my talk. So, all right. This one. All right. So, what I'll say about, actually, a small structure about my talk. I will give you some context. I will give some context about the presentation. I will tell you a small story how we passed from nothing to where we are now. I will say you where we struggled and what you can get from this talk. So, context. Here is how our system looks like at the scale. It's a network visualized connections between microservices. And we have more than 1,000 of microservices. And we are working delivery domain. And 5 different business units use the same system. It means that there not only one business, but 5 different for them. And this system maintained by more than 800 of engineers, including developers, quality engineers, and all different stuff. And the key business value of my business unit is find career. It's find order and provide technical capability to start an order. It's also called business core. You need to understand that, and please remind this slide. It's kind of important. And we have kind of different processes from enterprise. We don't have so-called product architects who design feature, who design how it should be implemented and which technologies to use. Teams design by themselves all the process. But we have central arc review process for new microservices. And we have central arc review process for complex technical issues, like we can split monolith to microservices. We want to implement new protocol and something like that. And in systems huge like that, there are some problems. First, and the most important, that experts leave. Experts is quite a deficit resource, and if some deep expert leaves, then probably you have some deep issues in your like maintainability. If someone who knows system very well leaves and you got into an incident, then probably you will have some lack of knowledge. Incidents happen sometimes because of microservices. And yeah, you can just do anything about that. It just happens. And the load grows, meaning that if business wants new feature, it means that new clients can come to your business, and it increases your load on microservices. And some limitations of our world is that hardware is limited. Even we live in better place, hardware is always limited. You just can't get all hardware of the world and a little bit more. Human focus is limited as well. Probably you can focus on 1 or 2 things very well, but if there are more than the 2, for example, if you have 2 microservices and you need to focus on 1,000 of microservices, probably you will lose some focus. And the human time is limited as well. You can't support all of things in a system like that. So we can formulate some meta problem from that our system is dynamic, and we don't rule the chaos which happens inside this system. So, and our goal is to prioritize which microservices are important for our system. But how? And here is some of, like, for technical folks, is to use some technical metrics. Please raise your hand who thinks that we can use technical metrics to say which microservice is important. Right? Okay. And just two of you. Right? No. Okay. So let's take a look. One of the most common metric in microservice world is requests per seconds. So, for example, you have system of 3 microservices, like first one, second, and the third one. For first one, we have load for 1,000 of requests per second. For second, we have 100, and in sum, they give like close to 130 RPS per requests per seconds. So I have a question for you. Please raise your hand who thinks that first one is most important, is most critical for your business. If it goes down, just nothing will work.
We can't tell yet.
Yeah, you can tell problems instead of.
All right, that's
So third one is the most important because is the other because at least two dependencies.
all right. So okay, so a smart audience. So please raise the hand who thinks that first one is most important. Right. And second one. Okay, so as I said, you're quite smart one. Correct answer to this one, that not to raise your hand, because you don't have a business context. You don't know how it works. Yeah, because in complex systems, it can be like first one is just shows some points on the map, and the third one gives some information about these points, like color or the name of the courier or something like that. And second one is a microservice, which is a microservice, which is important to your business. And in real systems, if first one goes down, probably nothing happens. You just don't see the points on the map or whatever. If second goes down, it means that your business has complete downtime. And if third goes down, probably second one has some fallback, like don't show information, don't show points on the map or whatever. So it can be somehow protected. And we can say that we have different problem, is knowledge. So knowledge is often siloed between different stakeholders, between developers, between architectures, between reliability guys, between business owners. And every stakeholder have different understanding of what criticality is. So developer can say, okay, some shitty code is critical, we need to fix that. Business say, no, actually this one is quite important, don't touch this. And it can be very, very different to have some common ground for all of them. So, and the top data meta problem is system has dynamic nature. It's knowledge, it's people inside this system who supports it. It's how components connected between each other, and it's of course knowledge. Knowledge is mostly chaotical part in this one because it's often changes, it's often updated, and you need somehow to keep track on that. So how we can fix it? We can make some standard. And we came with idea for criticality tiers. Basically, it's a way to define how critical for a business exact microservice. Okay, and the focus resources distribution. We have 4 different levels: A, B, C, and D. A is mostly important, and D is okay. It's we can skip this.
Can die.
It can die, and it can be not up for like I don't know for some time. And we came with first version. We defined key business value. It's this one in our case: find courier, find order, and provide taking capability. Basically, we sat with our CTO and the business owners and the experts and said, okay, let's focus our attention on something important. And we came with this idea. And we defined criteria for this key business value, saying that, okay, if service goes down and we can lose not more than X orders. If we lose more than it, we say that this microservice is important, and we say it as array. And we designated only these services and made markup in YAML files. Cost of the service. We have all infrastructure as a code thing, so we can allow one or two more YAML files. For second version, we define B, C, and D tiers, the lowest tiers, and stick criteria to key business value. We are the time impact and something what is important for our business. And at this point, other business units came with idea to adopt a practice, but with their own interpretation. We extended our YAML file, we added new fields to it, and if you take Qase, probably you can ask which actually critical tier we have, because it's like A and B and kind of mixed, and no one can answer the questions. So, and we faced challenges at this point. Single service can impact multiple businesses, and each business unit use different interpretation of these tiers, like tier A, tier B, tier C, tier D. And can you imagine what problem we faced with it?
Conflicts.
Here's a hint for you. Basically, it's kind of Babylon tower, and if you logical feeling gut, you can say that here's something wrong. It actually is. I will skip this explanation, but it is. For example, if we follow this rule for tier A, it can be kind of different logic happened here. And cognitive load for maintainers of microservices also increased because we have different interpretations, we have different definitions. It's hard for maintainer to say which tier is the microservice. So it kind of looks like this one. Different businesses says, okay, it's tier B, it's tier A, someone doesn't know, and maintainer just completely lost in this conversation. And our current version is kind of solves these challenges. We have basic definition of criticality tiers, very high level described, and concrete businesses inherit them with their own interpretation and extend by criteria. It's kind of open, I think, and it's tied, the tier tied to on-call responsibilities and reliability requirements. And of course, business owners know about this thing, so they can speak with us on the same language as we are. And what tier impacts? It's first and mostly important for maintainers. It's impacts on-call duties. For tier A, we require instant reaction during night and weekend. For tier B, we extend this for 1 hour reaction time, and the C and D can wait till business hours. Of course, if incident happens at the business hours for tier A, tier B, it's also required immediate assistance. So yeah.
On-call manager, on-call engineers ignore C and D incidents during nighttime.
During nighttime and during the weekend, yeah, they don't ignore. They just ignore. They even don't have others for this one and calls. And for A, B, they need to pick up the phone. And it's tied to reliability requirements. For tier A, we require highest possible availability SLA and of course hardware and all this stuff. For tier D, it's lower availability SLA, and we have in a system platform and platform features basically something which closes CVEs and all this stuff, and all these features for platform have strict rollout order from lowest tier to highest tier, because if something breaks down a system on the lowest tier, it's okay. If it breaks down mostly critical things, is just disaster. You will have so much trouble to roll back platform features. So, and the freeze, like code freeze, architecture freeze, change freeze, whatever freeze, applies on the tiers A and B because we want them to be as much stable as possible. And C and D can be like rolled out. Probably nothing that much happens. And we have processes how to assign the tier. First of all, is by whom it should be assigned. We found out that service maintainers own the accuracy of the tier. They are most responsible people in the room who should set the tier and do all the stuff to update it. And the change request can be made by incidents managers or by business owners.
Change to the tier level.
Change to the tier level. If we have a service which microservice, which is important for color, I think, and the business owner says, okay, this is like mostly important thing. They can initiate change requests. They need to go
And justify, I guess.
and of course, yeah, sure. And we have processes how to set the tier. Probably all party members should be involved in it, like business owner, incident manager, maintainer, reliability team, and it should be discussion. Tier A always passes architecture review.
Extra six.
Extra safety, exactly. It doesn't matter if maintainer want to decrease the tier, they need to pass architecture review. If they found out that it's actually tier A, they need to justify why it's tier A and they need to do to decrease the tier. And we have most important tool in our instrumentary is fault injection testing. Basically, we shut down the service on the production environment and see how system behaves like. If we shut down our microservice and it went down and our system, well, it's okay. We don't see any drops in business metrics, then it's probably COD. If it's completely disastered or key business metric, then it's probably tier A or tier B. And it's of course should be done periodically. For different tiers, we have different periodicity. Like for tier A, we have, I don't recall if it should be
1 month.
no, once per quarter, because it's sorting change. For tier B, it's half a year. And, okay, sorry, I forgot. Tier A, we don't drill actually. We already know that tier A is most important thing, so we don't drill it at all. For tier B, we do it once per quarter, for tier B, once per half a year, and for tier D, we do it once per year, because it's not important, whatever. And drills made by maintainers, as I said, they are owners of the tier, so it's their responsibility. And we have tooling for these processes. No process lives without tooling. And three most important is knowledge freshness. Why knowledge? Because when you drill your microservice, when you shut down it, you get some knowledge about your system. If it goes down, then okay, it's important. If it's not goes down, you know that it's not important, so it's knowledge. And we have convenient fault injection drills tooling because we delegate it to the teams. They need no tension between this one, so they just want to click button and sit and take a look for like 5 minutes what happens with the system and just write report and forget about for like some period.
Press a button to shut down this microservice, and then they see what happens, yes?
Yep.
But
It actually depends on your like criteria for critical tiers. In our case, we have understanding that 5 minutes is important for us. If a system goes like if we for tier A we have for tier B, sorry, we have drills for 5 minutes because probably it's kind of impacts on our business because it's tier B, it's kind of high tier. For tier C and tier D, we ask the team to do drills for 10 or 15 minutes because it's not so important and probably impact not so high. So we want to be sure that it actually doesn't affect our system. So, sorry?
People do it read about this to know your people like couriers, for example, that they is service be available and no worry.
No, we don't.
Peer support just going crazy.
No, well, I had two answers for this one. First one, we don't let our users know about this one, because if Drills passes good, then nothing happened. Why we want to disaster customers? For our internal users like support or PR guys or whatever, we actually have high visibility on what we are doing. We have designated chats, we have designated alerts, we have a lot of toolings who says, okay guys, in like 1 month, in 1 week, in 1 hour, we have drills, please pay attention here, what can happen. We require maintainers to write in details from business point of view what can happen if their microservice went down.
So the support will know
Yeah.
what to expect.
And support and PR and different maintainers and incident managers, it's one of the most important parties, internal visibility. Yeah, and we have tool for tier lookup. Basically, you can just grab tier A and find all these services. About fault injection tooling, actually, I gave talk at Vitaly meetup at Berlin, so here's the link. If you're interested in how we delegated case engineering, aka fault injection testing, to the teams, here's QR code. And where we struggled? Well, we struggled a lot on this process. It's like was 3 years of struggle for us. First is defining key business value, because you have so different stakeholders, so different party members. You need to gather them. You need to describe why it is important. You need to find common ground, how you define key business value. But this is first and most important step on this path. Defining clear criteria. Well, if someone tried to find a good metric, this is it. It's all about criteria, and you need only one metric. When you define this, you probably have like tens or dozens of them, but you need only one, maybe two. Well, yeah, different problem is that between different business units, we had different definitions. And when we speak on different languages in systems like that, it's like a way to disaster. And of course, it's a disaster for maintainers as well. And the most bad thing what we did is that we assigned tiers at first without maintainers involved. So we just came to maintainers and said, okay guys, now you are tier A, or now you're tier B. And they was completely not agreed with it, because it means that they was like yesterday tier C, they can sleep at night, sleep at business, sleep at weekend. And now they tier A, they need to grab the laptop with them, they need to be on the phone. It's just people does like that. And by forcing the process, we actually delegating the process to maintainers, we made clear contract with maintainers that they, okay guys, if you want to get some rewards on period review, or you can take responsibility and be in tier A. If you are not ready for this, okay, you can go and find some product or microservices for
Tier C and D.
tier C and D and sleep well at night. Yeah, and what it get for us? Here's our tiers distribution. We started this thing in 22, and we had like 30 critical services. At the time, it almost not grown, but at this year, it's kind of improved increased in number, yeah. Because we split monolith to different microservices.
What Microservices?
My microservices. And our reliability model changed a bit. And it's how it's distributed by different tiers. And this one is actually unmarked services. Because we started when we already had a lot of them. Some not market. But since we forced it process with periodicity, we hope that this goes down to like the end of this year. Yeah, and of course, we want less critical services number than DNC lowest, because we can say, okay, this one is most important, so we can flood it with hardware, and we can be more reliable just by hardware, and we just keep focus on the incidence measures on the most important thing. So you want this number low. So benefits, as I said, we can prioritize hardware. For Qase is heavily resourced with CPU, with RAM, with disk, or whatever. And Tier D also gives resources, but less. And in hard times, we can take some resources from DNC and give it to Tier A. We get clear rules for on-call engineers. As I said, it's just clear contract with the people who works for you. They can know what they can expect in future. Or probably they can plan some work to make a system more reliable by decreasing the criticality of the service. We get better observability. We have so-called main dashboard of health of our system. This, it's kind of part of it, where we have health dashboard for Tier A services. This is one situation, and this is second. So looking by a second, you can probably say that, okay, we probably have some error. We probably have something going on because this one service is kind of low, and this one is kind of low because you can see, hop. And yeah, so we got better observability on this one. And we also, different part is that we got smooth onboarding, meaning that for a newbie in the reliability team, we can say, okay, we have tiers conception, go use your favorite tool and grab all tier A services, microservices, and just you will be looking on them all the time. So, and what you can get from this talk, if you from large company, probably you have something like that, and you can see our approach and our struggles, and you can part of it. If you're from middle-sized company, probably it's time to think about what is really critical for you. And if you're from small company, you can see how big guys scale and scale reliability.
And for any company, like mid-size or small, you can apply more QA efforts to your critical tiers. Even if you don't do fault injection, you can still have your QAs spend more time on criticality.
Pretty much true. Yep. So you can focus more efforts on what is really critical for you. Fault injection is just a way to get some facts if you're from data-driven company who wants have proven stuff. So, and that's it.